Hello, in this video we'll be discussing the current progress and future of our project. We are Team 29 and we worked with NTT Data and Great Ormond Street Hospital to design a new solution that provides data to doctors working in sleep studies to diagnose sleep disorders. The currently and widely used polysomnography is not very effective on child patients, as it requires them to be very still. However, the use of multiple wired sensors allows doctors to measure heart and respiration rates, chest expansion, and oxygen saturation. These are key patient vitals needed for doctors to diagnose accurately. Nevertheless, in the case of child patients, wires can be found to be uncomfortable and even become dislodged during movement, leading to loss of data. Many solutions were proposed to solve this problem, one of which being the home sleep study kits. This system uses simplistic polysomnographic sensors designed for use at home. This allows patients to sleep in the comforts of their own homes, which would be ideal for children. However, the issue of multiple wires still leads to discomfort and loss of data. Data is also only stored locally, so doctors must physically retrieve the data from their homes, which reduces the scalability of the whole system. Another proposed solution is the NTT smart t-shirt called HITTO. It has an electrocardiogram and posture sensors integrated into the fabric. The data is transmitted through Bluetooth to an Android application, where the vitals are displayed graphically. This allows the patient to be comfortable and reduces potential data loss. However, not all vital sensors are included in the HITTO that are required for a thorough sleep study. Data is also only transmitted in real time, and doctors would not be able to view vitals from the past. We had to consider our user requirements before designing our proposed solution. It must have the required sensors for transmitting data in real time via Bluetooth to our application, which should then be stored in a database and allow the user to look back through the previous data. And we should also consider some additional sensors. On top of that, we should have a layer of security to our application. Our approach to this problem is to use NTT's smart t-shirt that will measure certain vitals to replace the wired sensors. However, through modifications, we will redesign the Android app as a middleware to transmit data from the t-shirt to a web dashboard in a cloud infrastructure. The transmitted data will be constantly stored and accessed in a MySQL database. The dashboard can then be accessed securely from a client PC. To create the web dashboard, we used a framework called Razorflow. This will allow us to create a quick, responsive, and real-time dashboards. The framework uses HTML5 and PHP. We are using Azure SQL for the cloud database and integrated it to Linux virtual machine using Azure Cloud Computing Services. The web dashboard will be running on a virtual machine. Implementing the system through a cloud infrastructure also allows doctors to be able to access the data remotely, provided they have the required security profile. Cloud servers also provides data backups and storage, allowing doctors to search for patterns and trends in past data. To solve the issue of the missing sensors on the HITTO t-shirt, we will integrate additional hardware such as a conductive cord stretch sensor connected to a microcontroller. This is our current prototype. Once the data is coming in real time, the doctor should be able to see any abnormalities or label the sleep stages as they please. This timescale at the top would also allow them to go back in time and see the previous data from that night. The widgets showing ECG and heart rate are all as the doctor specified, so the doctors would be able to use all this data to make their final diagnosis. Because our solution will be developed as different components and then integrated together, both component and integration testing is necessary. The component testing will allow us to make sure there are no errors related to each part of our system. The integration testing will allow us to see whether the system works together as a whole. On top of that, we would also be testing to minimize noise that the HITTO t-shirt produces from the sensors. Deployment in the future would involve hospitals obtaining the HITTO t-shirt and the app and purchasing credit for the cloud servers and storage. They would have a login to the web portal where they would access the data coming in from a specific t-shirt. The t-shirt would have to be synced up to the mobile phones, which would then automatically transmit the data to the cloud servers. The startup cost would be the HITTO t-shirt and the additional sensors, along with the Android phones containing the app. After that, the operational costs would be the maintenance of the cloud servers and the cost of storing all the data in cloud databases. The operational costs would be the largest, as depending on the amount of data needed to be stored and the amount of doctors accessing the web portal, that cost would vary. This wireless and easily transported system could see use in home sleep studies, as opposed to conducting them in hospital wards. This would mean that the space constraints are no longer affecting its accessibility. We are also considering the use of machine learning in the future to introduce automatic data evaluation. Thank you for listening. Please feel free to visit our website or email any of us with any questions you may have. Thank you.